All right, so welcome to part 2 of our exam review. In part 1, I went over the true-false questions. In part 2, we're going to go over the multiple choice questions. Now, these are really suggestions they're really good suggestions, but I do not mean for this to be an exhaustive list. I've done my best to make it pretty exhaustive, but I did tweak the final a little bit this morning, which doesn't necessarily correspond to this slideshow. But for the most part, this is everything. If you know everything on here, you're going to be really, really well. So let's go through the multiple choice. What makes an observational study an observational study? So you might be asked to differentiate between whether something is an observational study or whether it's an experiment. And remember, the key to an experiment is if you apply a treatment. If you don't apply a treatment, then it can't be an experiment, so it's most likely an observational study. You're just watching and see what happens to a group of people and recording the events, which doesn't mean you can't learn something from it, but it just means that it's not an experiment, so observational study. Oh, you'll need to be able to recognize an SRS. Remember that simple random sample? And stratified and cluster sampling, systematic, convenient sampling. So a simple random sample, remember, every group in the population has an equal chance of being selected. Now, to review stratified and clustered really fast, stratified would look like this. Here's my population. I'm going to divide it into strata, or different groups. And then from each group, I'm going to pull out some. So I'll pull out some from there, some from there, some from there, some from there. One from each strata, or one from each group. The difference with a cluster sampling is I'm going to divide the guys up again, but then I'm going to sample an entire group. So for these, I would like them to be different. I'm sorry, I'm pointing, you can't tell. Okay, I was pointing at that, you couldn't tell. I want these to be different representation for each kind of characteristic. And then for this, I would like each of these clusters to be the same, but by being the same, representative of the whole population. All right, systematic sampling. Remember, you'll want to randomly select a place to start. So maybe I randomly select here and then select every however many one. So I'll say every third one. So then that would be 1, 2, 3, sample him, 1, 2, 3, sample him, and so forth and so on. And then convenient sampling is just what it sounds like, doing something that's really easy. Maybe I want to find out what kind of music high school students across the country listen to. So what I do is I poll people here at good old MPCS. And that would not be a good sample. Well, maybe it'd be a good sample, but it'd be convenient. Look for flaws in the study. You might look for a lack of control or confounding variables, the presence of different types of bias. And basically for this question, you'll be presented with a type of study, and the study will be described to you, and you're going to tell why that's not a very good study. Different types of bias that you want to look for. I think we covered them on the other video. That was a long time ago. That was this morning at like 7. Now it's like 2. Under response, or no, I'm sorry, non-response and underrepresented. And that sort of thing, lack of control. And confounding, that's when you have two variables and you can't tell which one's doing what. So that makes it bad for the study. You will have to figure out what an explanatory and response variable is in a situation. And you also have to know what an experimental unit is. And remember, that's the smallest unit on which treatment's applied. If you need a quick review on explanatory and response, response is what you're looking in the change for. So maybe I have a new heart pill that I want to see whether or not it lowers cholesterol in your heart. And so, in your blood, I guess. So anyway, you're looking at cholesterol level would be the response, and the new drug would be your explanatory. This video is really boring. It's because Ashley and Anna Kim wouldn't let me play Christmas music. So it's just not nearly as much fun. Alright, you have to distinguish between stratified sampling, replication, blocking, systematic sampling, and double-blind trials. And we've kind of talked about this. We talked about the stratified sampling, you know what that is, and the systematic sampling. Alright, replication means that you use multiple units. Blocking is when you separate by some characteristic. So if I go back to the one I was talking about with cholesterol and the new drug, then I might want to separate those into males and females to eliminate gender as a possible variable. And so what I've done is I blocked these together and I have made gender go away. Remember double blind? That is when you have subjects over here and testers over here. I think that's how you spell testers, I don't know. And then they don't know if they're getting placebo or real. And pass it on to the people that only the testers know if they're getting placebo or real. And then the people that evaluate don't know if they got placebo or real. So these guys are blind, these guys are blind. Only the testers know who's getting the real treatment and who's getting the placebo. So that's double blind. You need to know how to conduct an SRS. So let's say we have 280 students at MPCS, and I want to conduct a simple random sample of 50 kids. Alright, so what I might do is put 280 pieces of paper in a hat. And I'll let 1 to 50 be my test subjects and draw until I've selected that 50. There's my hat. I'm going to put the numbers in. Alright, let's see what else we got. Make a relative frequency table. So let's pretend I had lots of time and I was rolling a die. 1, 2, 3, 4, 5, 6. And I roll that die and I roll it a number of times. I want to see if this is a fair die or not a fair die. Alright, and so my frequency would be 2, 5, 3, 7, 1, 2. How many times I roll it? 8, 13, 16, 23, 24, 26. Oh boy. Couldn't have done it 25 times where the numbers would be really easy to do in our head. Alright, and so the relative frequencies will be 2 over 26, which is 1 over 13, and 5 over 26, and 3 over 26, and 7 over 26, and so forth and so on. So if I were holding my calculator, which I am not holding, which reminds me, you need to make sure you bring your calculator tomorrow because my calculator's in big yellow bins, and I made sure I packed it on the bottom one at the bottom so I couldn't get it out. So make sure you have your calculator with batteries and you know how to use it. But anyway, if I had that, then I'd convert it into some sort of decimals. and that would be my relative frequency table. I don't know if we're going to have to do it, but remember cumulative frequency. To do that, you just add these. So this first one's, let's stick with 26 so I can actually do the arithmetic. That would be 2 over 26. And then I'm going to add this 5 over 26 to it to make 7 over 26. And then 10 over 26. And 17 over 26. 18 over 26. 20 over 26. Somewhere something went horribly wrong because it should have added up to 26 over 26. But that's the idea. I add this one to this one. And then add that one, so forth and so on. Seventeen, 18, 20. Oh, there's my mistake. That was 20 all along. Maybe I added the F as a 6. I don't know. So those would all have been over 20. And then the arithmetic actually would have been really easy. But that's why I didn't add up to 26, as it were all 20s. Alright, so you can either fast forward and pretend that didn't happen, or rewind and watch it for hours and hours. Alright, make a comparative bar chart. And that's a bar chart comparing different categories. And so we might have the categories of young, medium, I don't know, and old. I think we had a question about a con chart or something one time about that. Alright, and then you just divide them up like this and compare. Rock music, rap music, country music, or whatever the other categories are. That must be classical music. But that's what a comparative bar chart looks like. And I do have these touching, which is okay. Again, I'm pointing, that's not a good thing. But I have these touching, which is okay, but I don't have all of them touching. Read a stem and leaf plot and recognize the shape of a distribution from the stem and leaf plot. So let's see, I'm going to make a stem and leaf plot. 0, 0, 1, 1, 2, 2, 3, 3. And then I'm just going to make up some numbers. Let's convert that to a 5. Alright, so to read this stem and leaf plot, I would have to have had a key, most likely, so that I know that 0, 6 equals 6. And so maybe the question will be, is there a mode for this? Which there's not one really. Let's make a mode. Okay, now we have a mode. So you can read this and see that 15 is the mode. And then recognize the shape of a distribution from a stem and leaf plot. So if you turn this to its side, which I am doing right now, but you can't tell, alright, then I would see that it kind of takes on this shape, which means the tail is out to the right. So you know what to do when the tail is out to the right. It's going to be skewed to the right. Oh, let's see what else we got. Read an ogive, which is a cumulative frequency diagram. So remember, ogives look like this. And they go up until they get to 1. And then there'll be some scale on the vertical side too that you read. But the tallest on there is the 1.0. And then these are frequencies below it, so that might be 0.8, 0.6, 0.4, 0.2, and 0. And then you can read. And these might be, you know, whatever the categories are. But remember, we went up and over. And for some of these, I don't think you get to do it tomorrow, but for some of these, you could tell out what percentiles were. You could go to here and read like over at 75 and down and get a value. We did those with ogives or cumulative frequency diagrams. You'll do something like that tomorrow. Find the mean standard deviation of a sample. So this is really a calculator exercise, and that's why I told you to make sure that you bring your calculator, because you'll put your numbers in L1, whatever numbers they are. I mean, you can do it the other way too, but this is the easy way. Put the numbers in L1 and then do stat. Sorry, my phone was, well, it was ringing, but not really. It's on silent, but it's kind of like that. Anyway, stat, calculate, 1var stat, and I think it defaults to L1, but why don't you go ahead and put what list in there you want it to be, just in case, so that you're sure. And then you'll want to give X bar and you'll want to give S. Make a box and whisker plot given the 5-number summary. So you get the 5-number summary, you get the min, you get the max. You get Q1, you get Q3, and you get the median. So let's say the min is 1 and Q1 is at 10 and the median is 12 and Q3 is at, what sounds good, 15, and let's have a max of 24. All right. You can test for outliers using the IQR. So the IQR is 15 minus 10 is 5, and then 1.5 times that is 7.5. So if I go down 7.5 from Q1, I only get to 2.5, so maybe that min is an outlier. And if I go up, then that max would be an outlier given those. So I would need other values to plot. But if I didn't have any outliers, let's make that a 7. So we don't have any, and let's make this, let's see, we want to go up to 22, so we'll just kind of make that a 20. All right, you can plot your 7 and your 20. Remember, you're going to have a horizontal axis down here with numbers, and then this is at 7, 8, 9, 10, and this is at 15. There's my box between the quarters with a line for the median. And you'll kind of want yours to be straight, not like mine. But this is in the multiple choice part, so you're actually picking from diagrams. So you will want to check for the outliers. And remember, if there were outliers, then they would look like that. All right, let's see what other fun stuff's next. Uh-oh. Oh boy, I've broken it. This happened in a geometry one. It was awesome. It made it much more difficult than it should be. Okay, probability question. Let's just make one up. Let's say you have a deck of cards. Let's find the probability that you get an ace. So we know there's 52 cards in the deck, and actually the question tells you that in case you don't know. And then the probability to get an ace, there are 4 aces in the deck, so 4 52s, 1 over 13. And there's 1 or 2, that's some of the stuff I changed. So I don't remember if there's 1 or if there's 2. Make a two-way table from given probabilities or results. So let's say that I had 5 males, yes, 2 males, no, 3 females, yes, and 10 females, no. Then you'll have a yes and a no. You'll have a male and a female. And then you can fill in the rest. And then you should be able to do this from probabilities as well. It would just say instead of 5 males yes, it might say 0.2 males yes, and 0.1 and point so forth and so on. All right, let's see what else you got. Conditional probability from a table. So if I just use this last one that I did, I could do the probability of yes given it's a female. So I'm only looking at females, so I'm only looking at this. So the probability of yes given it's a female is 3 over 13. Okay, so I've gotten to this slide, which tells me that I'm at the end of the multiple choice section. So again, there are, and now these are approximate signs because I did it this morning. And then I removed all the questions I wanted to and added what I wanted to. So these are actually equal signs. You're going to have 50 questions tomorrow. And it's not quite as scary as it sounds because I think the true false go pretty fast. Multiple choice isn't as tricky as the other ones that we used to use. And then the free response aren't as in-depth. Although we'll talk more about the free response in a second. All right, that was part 2